questions, so you can keep your hands up about things.
Can you just say a little bit more? So the co-event is like a function from histories to
Yes,
what?
to Z2. So co-event
Oh, to
the yes, no, to truth value.
yes, no, okay.
The space of truth value.
And then in the case where you don't rule out, I mean, do you have something like a principle of inclusion as well, in the sense that
Oh, that's a good question. So that's a very good question. So in this scheme we do not.
right,
But one might imagine a principle of inclusion that for every event that's not of measure zero, there is at least one co-event that affirms it. In other words, there's one possible way that can happen.
right,
That is not a principle. In the example, when these events are record type events, then as I said, there's a theorem that guarantees that that'll be the case. But more generally, it's not. And it's a very interesting, I mean, it's a suggestion that comes up, whether that would be a useful supplementation to the principles that I started with.
thanks. And just one more clarification. So in the case where we're in the actual world and there's more than one path through the interferometer that's possible, then, and no other measurements are done, then effectively they both happen, is that right?
Well, I would say neither, now it's a question of language, but I would say that reality is described by that pair of histories.
Right, so neither doesn't happen.
So in the particular language that I've adopted, it would be neither one happens, right?
Right.
Because you would,
But it would also be true that of neither is true that it doesn't happen.
no, it would be true, no, it would be, that
What I'm
would,
wondering
I mean,
is
it would be
what
the case,
classical
it would be
logic-
the case that, if I understood what you said, it would be the case that if I pick just one of them, it doesn't happen. Or if I pick the other, or maybe you said this, which is the event that either one of them happens, that does happen. But the event that this particular one happens does not, and the event that this particular one happens does not. That's the language that I'm adopting.
Okay, so I was just wondering why you had a classical logic there.
Well, it's not so obvious. So you don't have a fully. If you choose to use logical language to describe the situation, which we've just been doing, so
Yeah.
then you don't have a fully classical logic. If you look up, you have.
Oh, it's just you said it was a Boolean algebra.
You do have a Boolean algebra. Yes, the algebra event. Yeah, so that's a very also raises a very interesting discussion that we could have. But in this way of setting things up, the event algebra is still Boolean, but this co-event doesn't satisfy classical rules of inference. But it turns out that there's only one, if you look at a list of rules of inference, there's only one that this multiplicative scheme violates, and that's the rule that's never even stated. We used to call it the RRLO, or the rule that Russell left out, which is where he described all the rules of inference. And it's the rule that if some event A does not happen, so it's not true, but if it were true, it would say that if event A does not happen, then the event not A does happen. That's the rule that's violated.
Okay, thanks very much.
Dean? No, Lev?
You, as far as I know, Feynman never looked on his path integral as anything but just a tool. He never wanted to attribute any reality to these trajectories. Now you say it's reality. You present here some formalism and give some examples with some definite results, like strange results, and you have two Mach-Zehnder interferometer, and you say AA cannot be, or something which they're independent, which is if the word reality, you say it doesn't have direct connection, not always has direct connection, but does needs some direct connection to experiment. So what these strange things which you found, even with this two Mach-Zehnder interferometer, what is correspondence to experiment reality, to our observations?
Well, for example, we found, so I could answer two levels. I mean, first, I remember I said that if all you're interested in is computing Born rule probabilities, then the path integral does everything that you need.
What
So
type of
now
angle?
the second, yeah, so now what's the correspondence? So, in the case where I looked at 3 slit, the correspondence was,
3 slit you found that A and B.
right, but you could have asked, could this event D happen at all? Can the particle arrive here? And in some schemes you may find that it couldn't arrive here. So like the scheme that tells you represent reality by a single history would say that it couldn't arrive here. And same thing for those other paradoxes that I gave you. So that's the connection to reality in this case. But if you want to know what's the direct meaning of this pattern of events, this particular event here, A, not happening, or this event A or B, but not C, if you want to know what's the direct meaning of that not happening, it's something like asking, what's the direct meaning of talking about what's inside a black hole, or what's the direct meaning of talking about the primordial spectrum of density fluctuations in the early universe. There's no direct meaning. You have to go through a long analysis before you can relate it to things that we observe directly. Now, I'm not claiming we've done that whole analysis. This is the beginning of setting up a scheme. But this gives you a well-defined scheme in which, as I said, for example, the measurement problem is solved, or at least partly solved. So there's a lot of, I would say it's a promising scheme, but it faces this difficulty, which I tried to show, which is inseparability, which I claim I suspect any realistic version of quantum theory will face.
So, no,
Just, can you, what I would disturb by is the next example.
Okay.
This 3-box example, you get more or less this, but in the next example, when you look 2 of them, you said A has 2 independent interferometers, you get some kind of unusual result. Does it correspond to anything? Or well, maybe I didn't misunderstood it. You said AA is not possible if you look on 2 of them together.
That's right. Well, no, I didn't
What
say.
is the meaning? Well, this is kind of a result in the theory. What this result should tell us?
In this case, I don't know the direct meaning of it. But I just used it to represent a. Let me think a little bit. Can I give it? You can't give it a direct meaning, right? Because it's not dealing with direct experimental outcomes. The direct experimental outcomes would be: did the particle emerge in the horizontal port, or did it emerge in the vertical port? This is asking about what happened. It's just like your questions that you asked about what's going. Was the particle present or not? It has no. I mean, you've managed to give it some experimental meaning, but it's a guess, or it's a way of.
Only because,
No.
because I see weak trace, I think it has meaning. If it just has kind of formalism, I don't think it has.
Well, so you have an operational point of view, but I would argue once again that I think, like Adrian said, and when you talked, I would argue an operational point of view will never get us to the kind of image of reality that we need if we're going to do quantum gravity, or if we. Yeah.
And apologies to those of you who want to ask further questions, but we'll get the chance to do that at lunch.
Okay.
And we'll move straight on to next talk. So let's show our appreciation for that.